I can just hide, can I?
It's the same thing. So this. Here we go. All right. We're going to get through this kind of quickly today. Do I need both of these? Yeah. Okay. I'm recording this today, but today is a late start, so we only have 35 minutes, so we're going to power through this. I'm also not going to type anything into the calculator. I'll just write the number and we'll keep rolling. Suppose that P sub n of x is the nth degree polynomial approximation for the function of f about x equals c, and m is the maximum value of the next derivative. So P sub n is the polynomial that approximates a function, usually not a polynomial. And we're centered at x equals c, and m is the maximum value of the next derivative. So we've done the fourth degree polynomial. We have the maximum value of the fifth derivative. Then the error in using the polynomial value P sub n of b is to estimate f of b is bounded by. Now this looks really fancy, but think about how we build the polynomial. It's f of n plus 1 over n plus 1 factorial times x minus c to the n plus 1. That's the next term. And then the next term, and the next term. We just keep taking derivatives, divide by a factorial. For example, if you've done p sub 4 of x, then the next term is the fifth derivative over 5 factorial times x minus c to the sixth power. Or I was thinking the next term. Fifth power. And the next one, they'd all be 6s, right? The next one, they all be 7s. The next one, they all be 8s. The next term. But this gives us a little bit of trouble, being the maximum value, and we'll cover that. We'll talk about that. Thank you. This assignment's page 37 in the packet. Find the fourth degree Taylor polynomial for e to the x centered at x equals 1. So old news. P sub 4 of x is e to the first, right? We're centering at 1, e to the first. And then all the derivatives are e to the first. Plus e to the first times x minus 1. Plus e to the first times x minus 1 squared over 2 factorial. And then the next derivative would be e, and that's x minus 1 to the third over 3 factorial. And then the next one is e, and then x minus 1 to the fourth over 4 factorial. Fourth degree? Yeah, fourth degree. So I stop there. The next one would be the fifth degree. That's the n plus 1. Our n is 4. The n plus 1 is 5. It's one more. Estimate P sub 4 of 1.2. Here's where I'd throw this into the calculator. We're going to try to save some time because we got short periods today. P sub 4 of 1.2 is 3.32, 0.109, 425. That's an estimate. So we got the estimate. I'll get out of the way. Exact is f of 1.2, or exact to this many decimal points, 3.320116923. So our estimate is about 4 decimal places good, right? About 4. It fails right at the 5th. Yeah. If we subtract these two, I actually don't trust my answer. I don't think it's right on this paper. I'm going to do it very quickly, or as quickly as I can here. 3.320110923 minus 3.320109425. 5 zeros. 0.12345. 1498. 1498. That's the error, right? Because if we take exact minus the approximate, that's the error in our approximation, at least to that many decimal places. The question I ask is, what is the 6th term? In other words, the 5th degree. So in other words, what would I add right there? What is the 6th term? The 6th term would be e, x minus 1 to the 5th over 5 factorial. So if n is if n is here, our remainder of fourth degree is less than or equal to the maximum derivative divided by 5 factorial and then x minus c to the 5th power. That's the next term. That's the first omitted term, we say. Evaluate the maximum error for the 4th degree Taylor polynomial. In other words, evaluate this. So this is e times 1.2 minus 1 to the 5th over 5 factorial. This is the maximum error that we could possibly have. And when you plug this into the calculator, I got, oh, no. Let me stop for a second. Because I'm thinking about a problem on your homework. E is approximately 2.718. Let's say, I'm going to change topics on you real quick. Let's say I'm guessing that you had $15 in your pocket. And you go, nope, you are about $2.90 off. I'm like, okay, I mean, am I $2.90 off or about or what? And you go, and you're vague. You go, about. You're playing with me. You're messing with me. You're about $2.90 off. And I go, all right, I'll say that I'm $3 off then. So you told me I'm $2.90. I'll say that I'm $3 off. That way I guarantee that you have $12 to $18. Would you say that you can guarantee that you have 12 to 18? I gave you a range. I know that's the amount that you have is in there somewhere. Because you told me the most error, and I go, I'll make it a little bit more, just to be safe. So I did this worksheet that I think you're going to do 12 years ago when I first started teaching BC. And I typed all the numbers in and hit enter, and it was wrong. I'm like, dang, I mean, I make mistakes too. I enter stuff in wrong, and I'll write 3 factorial as 8 or whatever. I make all these little mistakes, but boy, I worked it again, I worked it again, I worked again. I couldn't get it. Like, I know I'm doing this right. What's wrong? Well, they made e equal to 3. I'm like, that's kind of strange. But they wanted to make sure that the interval that they have contained the exact value. So that's what they do. So I almost wrote the wrong answer to this. They make it 3 instead of e. Once I typed 3 in, I got the answer on the worksheet. It was frustrating. But I'm warning you, if you plug in e and you're getting the wrong answer, try 3 and I'll bet you get it. All right, anyway, with 3 in there rather than e, we get 1, 2, 3, 4, 5, 8. That's the maximum error, and that is still, we have less error than that. 1, 2, 3, 4, 5, 1, and the most error we can have is 1, 2, 3, 4, 5, 8. So we are under that maximum error in our approximation. Give an interval that must contain f of 1.2. So we do approximation minus the error is less than the exact answer is less than the approximation plus the error. And that's exactly what I did in our little example. I guessed 15. You told me I was $2.90 off, so I go, well, I'll make it 3. I subtracted the error, and I added the error and said, well, you have $12 to $18 on you. I know that. I can pretty much guarantee that. All right, so now when you do the subtraction, when you take the estimate plus or minus the error, and I don't think I have the right answers on here. So let me do this very quickly. Here we go. I said I wasn't going to do this, but I want to. 320109425 minus 0.123458. So 3.3201. 3.3201. 01425. 01425. Is that what I had? Yeah, that's what I had. Okay, this is good. F of 1.2 is less than 3.320117425. So I know that the exact answer must lie within that. And if you look, I gave an example where you can actually find it. That is inside of that range right there. that maximum value concept, we'll come back to that. Any questions on what we've done so far? Let f be a function that has derivatives of all orders on the interval -1 to 1. Assume all those derivatives. And this is a little different. They say that the fourth derivative is less than 7, which means they're telling us that the maximum that derivative could possibly be is 7. Find the third degree Taylor polynomial for x about x equals 0 for the function f. So p sub 3 is 3 plus 1/3 x minus 1/9 x squared over 2 factorial plus 4 over 27 x to the third over 3 factorial. Oh, and that's it. That's the third degree. And we stop there. Use your answer in part A to estimate the value of f of 0.4. So the estimate for 0.4, I'm going to use the polynomial. So when we plug this in, I'm going to fast forward 3.126024691 is the approximation. Now, the difference between the one before and the one now is we don't have a function to check what the exact is. All they gave us was the derivatives. We don't have a function to plug it in and go, well, let's see how close we are. We don't have that. So now we have to use math to find out how far off could we possibly be. What is the maximum possible error for the approximation made in part B? So now our remainder, in other words, the error of third degree, when we plug 0.4 in, is less than or equal to the absolute value of the maximum value of the derivative, so the next derivative, in other words, and they said the maximum value could possibly be 7. So that's how far off we could be. For the derivative could be 7. And we're not going to round 7 to something else. Over 4 factorial, because we're looking at the error for the third degree, so now I have 4 factorial. And then we're centered at 0, so I wouldn't have to do this. I don't have to put in 0.4 minus 0. That's not necessary. It is when we're centered somewhere else, to the 4th power. So our error is less than or equal to 0.007466666. Keep on going. Now, we don't have an actual function to check to see if that's what our error is actually less than, but I know it would be because it's always less than the first omitted term. It has to be. All right, so now we give the interval that must contain f of 0.4. So we take approximation minus the error, approximation plus the error. And when you do that on a calculator, you get 3.05135.802. Now the actual value is somewhere in between here. Now we don't know. We just know by the math that we just done. We just have to be confident that we made all the calculations. The whole focus of today really is the next term. I can't stress that enough. Getting the next term. The error is less than that. Now there's other pieces to it, finding the range and a couple other questions, but the main focus is if you can get the next term, you're good to go. Let f be the function given by that, and let p of x be the 4th degree Taylor polynomial for f about x equals 0. I should say find p sub 4 of x is what I should have. So f of 0 is sine of 2x plus pi over 4. And then when we plug 0 in, we get square root of 2 over 2. Now we got to get to the 4th derivative. Here we go. Here we go. 2 times cosine of 2x plus pi over 4 is 2 cosine of pi over 4. So 2 square root of 2 over 2, it ends up being square root of 2. Second derivative, negative 4 cosine of 2x plus pi over 4 is negative 4 square root of 2 over 2, when we plug 0 in. So negative 2 square root of 2. Two more. Here we go. Third derivative. Negative 8. I almost wrote 4. 8. Yes. Oh, I need, you're right. I need sine here, and then this will make that cosine. Thank you. Sine here. Let's see, cosine negative and cosine. There it is. And that's negative 8 square root of 2 over 2 when we plug 0 in. So negative 4 square root of 2. And one more. Fourth degree. 16 sine of 2x plus pi over 4. So 16 square root of 2 over 2, 8 square root of 2. Yikes. A lot of work. A lot of tedious work for this. P sub 4 of x now is equal to square root of 2 over 2. We're centering at 0. So plus square root of 2x minus 2 square root of 2x squared, I don't know why I put parentheses, over 2 factorial, minus 4 square root of 2x to the third over 3 factorial, and finally plus 8 square root of 2x to the fourth over 4 factorial. Got it. If we plug the value in close to 0, oh, that's not just any value. If we plugged 1/4 into this, if we plugged 1/4 into that, and we got a value, that would be an approximation of the function. And we want to use the Lagrange error bound to show that the error in this approximation, the error in plugging 1/4 into this, would be less than 1 over 3,000. That's what we want to show. So the whole focus, the big objective today, is to think next term. So the next term here would be what? Let's see, the fifth derivative. Yeah, wouldn't it be 32, right? 32 cosine of 2x plus pi over 4. That's 32 square root of 2 over 2. 16 square root of 2 would be the next derivative, right? The next derivative. So the error, and they call it the remainder, of fourth degree is equal to the absolute value of the maximum over 5 factorial, and then we're plugging in 1/4. 1/4 to the 5th power. That's what we need. Now we need something in for that m. What should it be? 16 square root of 2? No. Great guess, though. That's the road I led you down. But that would not be it. And I can see the confusion, which is fine. I expected it. What should go there? It's not 16 square root of 2. What's that? It's not that complicated, believe it or not. It's less complicated than that. No, not a bad guess. 17? That's a good guess. I like that. No. Doesn't mean it's right. I can like it and still be wrong because it's a good thought. What does M stand for? Maximum the derivative could possibly be. What's the maximum cosine can possibly be? 1. 32. That's right. We're going to put 32 there. Completely counterintuitive. You're like, what? What are you talking about? We're going to round whatever 16 square root of 2 is, we're taking it all the way up to 32. Because that's the maximum the derivative of cosine can possibly be. Now, we don't have a lot of functions that can do that. We don't have a lot of maximum values for functions. What's the maximum value for e to the x? Infinity. It's infinity. We don't have a maximum value. However, we have okay, we'll take e to the first, that's 2.718. We'll just push that up to 3. We're not saying that's the maximum value, but we're saying let's give us some wiggle room so that we know the exact values in there. So that's what we're doing here. So sine and cosine are unique in that there is actually a maximum value for it because they're periodic. They go up and down, up and down. There's actually a minimum value for it too. So all of that work just to tell you that this is 32. That's really what I did. But you have to see it. You have to see it in all that mess. This ends up being 1 over 3,840, which is less than 1 over 3,000. So that's actually the final statement that they want to see. That what you get is actually less than 1 over 3,000. The trick on that one is knowing that that value needs to be 32. That's not easy. Questions? All right, with your partner, or turn around, or whatever you need to do, you don't have to read that box again. This is the alternating series test. They alternate. I want you to, I guarantee you that the calculations on this problem are very easy, but it's not so easy to know what to do. Give it a try. Very easy problem if you know what to do. Okay, you ready to be let off the hook? Here we go. What they're saying is, let p sub n of 1/2 represent the nth degree to the polynomial for x equals 0, value a when x is 1/2. Where g is the function f. Use the alternating series error bound to show that the fourth degree approximation, so approximation minus the exact, that's what G stands for. In other words, show that the error of the fourth degree is less than 1 over 500. So in other words, they've used this much right there to approximate it. And so here is the most the error can be. So 1/2 to the 5th over 20, which is 1 over 32 over 20. Now instead of dividing, we can multiply by the reciprocal, which is 1 over 640, which is less than 1 over 500. The calculations are very simple. Knowing to do that is the tough part. That's it. And I probably should throw that this is actually negative and that we actually do the absolute value of it. We report error always as a positive value. That's it. That's all you had to do. Next term. You just got to find the next term. That's it. And if you did that, that's great. If you're still catching on, don't worry. Do your homework, check the answers, ask questions. This is just the next term. That's it. You got to get used to it. You just got to practice it a little bit.